that resonance frequency of a series resonance circuit is equal to the geometric mean of two of-power frequencies. So this is nothing but F naught is equal to, or Fr is equal to, geometric means it is F1 into F2, root of F1 into F2. This you have to, this is an important question. Sometimes they will ask you to derive like this also. Show that omega r is equal to root of omega 1 into omega. So for this, if you already know the formula of omega and omega 2, you can finish within 2 steps. If you don't remember the value of omega and omega 2, then you have to start from the scratch. Okay. So I will show that easy method also at the end. You watch till the end. Okay. You can show if you know the formula for omega and omega 2, within 2 3 steps you can derive it. Otherwise, you can follow this method. So we know that in the impedance versus frequency formula, we have is a response. Okay. And at impedance at Fr, okay, we have Z is equal to Zr is equal to purely resistance acts as a resistance at F1 and F2. Okay, at F1 and F2 we have uh, root 2 times R, and we know that at this point we also derived expression. I'll show you the derivation for that. Okay, F1 and F2. Okay, here at a lower frequency Xc is greater than XL. As the frequency increases, Xc will reduces. XL is greater than Xc now here. So at resonance, Z is equal to R only. At F1 and F2 we have, okay, at F1 and F2 we have R is equal to XL minus Xc whole square. One time R is greater than XL is greater than Xc. In another side Xc is greater than XL. So based on that we can start deriving now. Okay. So at resonance, okay, at F1 and F2 in general formula, okay, this also you can omit. Z1 and Z2 can be written as the magnitude at lower cutoff frequency F1 is given by root of R square plus Xc minus XL whole square, because at lower frequency X is greater, Xc minus XL whole square. At upper cutoff frequency, you have to consider XL is greater, no? So root of R square plus XL minus 2 minus Xc2 whole square. C1 and C2 is nothing but F1 and F2. Frequency Xc is reactance at F1, Xc2 is reactance at F2. Okay, but Z is here, since current is constant here, it is I max, here it is Im by root 2. So here also these two impedances are same only. Okay, at F1 and F2 impedances are same, Z1 and Z2 at F1 and F2. So you can equate these two, root of R square plus XL minus Xc whole square is equal to, you can equate this equation number 1 and 2 and square both side. If you square both side, the square will remove R square plus XL minus Xc whole square. So this again you can cancel this and this. Okay, we left with Xc1 minus XL1 is equal to XL2 minus Xc2. So that is the meaning of at resonance at this point at F1 and F2. At F1 and F2 here we have Xc1 is greater than XL1. At this point we have XL1 minus greater than Xc2. So at resonance, okay, at F1 and F2, these two difference, okay, that is capacitive reactance minus inductive resistance is equal to inductive resistance minus capacitive resistance reactance. So Xc1 minus XL1 is equal to XL2 minus Xc2. Now you bring C2 capacitance on this side, this minus becomes here plus this L you bring to right side. Inductive reactance you bring it to right side, it becomes plus, and this capacitor reactance you bring it to left side, becomes 1. Now Xc1 is given by 1 by omega C1, Xc2 is equal to 1 by omega C2, X1 is omega L1, omega 1 L, Cl2 is omega 2 L. Okay, where omega 1 and omega 2 are nothing but lower and upper cutoff frequencies. So after that you take C common here, L common. If you take L common, we're left with omega 1 plus omega 2. Here, if you take 1 by c common, omega 1 plus omega 2. And after that, here you take omega 2 as LCM, omega 1, omega 2, then omega 2 plus omega 1, omega 2 plus omega 1, and here omega 1 plus omega 2. This C, you bring it to right side, cross multiply and bring it to here. And now you can cancel this omega 1, omega 2 plus omega 1 here also. Here also you can cancel, divide throughout by omega 1 plus omega 2. We left with omega 1 by omega 2 is equal to omega, this we can write 1 by over omega 1 omega 2 is equal to LC. Again cross multiply. Okay, this LC, this omega and omega 2 take reciprocal of both. Okay, omega 1 omega 2 is nothing but 1 by LC. Okay, so this you can write as omega 1 omega 2 LC is equal to 1. If you cross multiply, then omega 1 omega 2 is equal to 1 over root LC. Okay, this term you are going to get. But omega 1 by 1 over LC is given by omega r square, because omega r is 1 over root LC, and if you square both sides, omega square is equal to 1 over LC. So this 1 by LC can be written as omega r square, and omega r is equal to root of omega 1 omega 2. So this derivation is sufficient. If they ask derive this, omega r is equal to root of omega 1 omega 2, you can start from. So you can start from here also. At f1 and f2, we know that z1 is equal to z2, where at r1 we have xc1 greater than xl1, and the difference is this one. Similarly, you can write this one, and simplifying this, you can get this. So this is actually lengthy method. Instead of that, you can do easy method also. For that, you should remember the formula for omega 1 and omega 2. So we already derived expression for omega 1 and omega 2. I think this formula, this omega 2 and omega 1. If you remember this formula, omega 1 is this, omega 2 is this, then we can directly write that relationship between omega and omega 2 and omega r as consider omega 1 omega 2. We have to write, we know that, okay, we know that omega 1 is equal to this much, omega 2 is equal to this much. Okay, then consider omega 1 and omega 2. So this is in the form of, this is in the form of, this is in the form of omega 1. This is in the form of, you can consider this as a, and this as b, b plus a, and a minus b, a plus b, a plus b, and a minus b. A plus b into a minus b is a square minus b square. So we know that a plus b into a minus b is a square minus b square. So a value is this. So if I consider omega and omega 2, we will get a plus b into a minus b. So this will be equal to a square. A square means we will get r by 2l, then 1 by LC. This entire in this. That square means this square will get cancelled. This square will get cancelled. Minus b square. B square is nothing but r by 2l whole square. Now this will get cancelled. We left with 1 by LC. So we will get 1 by LC. So that, but 1 by LC is nothing but, okay, 1 by LC is nothing but omega r square. 1 by LC is nothing but omega r square. So omega r is equal to root of omega 1 omega 2. So once you know the omega is equal to omega 1 2, we know that omega r is equal to 2 pi fr, and this one 2 pi f1 into 2 pi f2. So it is root of 4 pi squared f1 f. So this is 2 pi. If you bring up this one f1 f2. So 2 pi fr is this. 2 pi will get cancelled with 2 pi. So fr is equal to root of f1 f2. This also we can write, or you can follow this method. Okay, both are correct. Okay, once you know that, similarly, therefore omega you can write omega is equal to root of f1 omega and omega 2. Similarly, omega R is 2 pi fr. Here 2 pi f1 into 2 pi f2, 2 pi root you will get pi 2 pi will get cancelled. You will have with omega fr is equal to root of f1, which is nothing but geometric mean of f1 and f. Is also a very important question.